To review the color theory behind this strategy, we have to remember that light is color. And most of the time we're in a situation where there's full spectrum color, that is, there's some kind of natural light. At night we sometimes rely on incandescent or other kinds of artificial light. But it means that the wavelength and frequency of all of those colors is present in that light. So it's possible to see the full visible color spectrum or range of colors in any given situation, right? Do we agree that it's possible, right? So that should help you feel a little bit more comfortable about inventing a color and putting it in there in order to strategically make the palette a little bit more juicy. So if there's warm light, remember there will always be cool shadows. And if there's cool light, there's a tendency to have warm shadows. And we studied last time this very interesting phenomena where the color temperature of the light interacts with the local color of the illuminated surface. And likewise, the color temperature of the shadow interacts with the local color of those surfaces that are in shadow. And also, we saw that the residual light in the room that's not being dominated by the light source tends to show up in those shadows too. And when that happens, interesting things. You can get some beautiful reflected light color. You can get reflected light both on the backside of an object and in a shadow. And all of a sudden, shadows take on light and space. And when they do that, they stop becoming these gray, kind of black holes where nothing's happening. And all of a sudden, there's this whole world that happens in a shadow. And there are artists like Rembrandt who loved that and painted, you know, even though they selectively illuminated their subjects, they painted vast spaces in shadow, right? I also wanted to remind you that because there's this complementary color relationship between light and shadow that occurs naturally, right, in nature. You have yellow sunlight, you're going to have blue-violet shadows. That when you put these complementary colors into your painting, you're painting according to natural law. And so what happens is it creates this unifying effect in your painting. And all of a sudden you breathe light and air and space into it. So in this example, I'm giving you a kind of a red-orange and a cyan blue, and they're almost the same value, okay? So your eye can't really rely on value to make a distinction between them. So it's relying more on the receptors on your cones in order to make that distinction. But I'm also giving you two complementary colors along an edge. Remember, everything happens along the edge. Okay. So what I've done to help you understand what we're doing today is I took the same two colors and I'm giving you neutralized versions of them. But, and then I'm putting them together along an edge, and I want you to look at them singly first, and you can see, wow, that just looks gray, right? How about that one? Yeah, kind of gray-blue. But notice what happens when you look at them together. Does the gray on this side start to look warmer? Right? That's the first thing that you want to look for, is simply to see if it shifts it warmer or cooler in the same way that we would normally look at two colors along an edge and say, does one look lighter or darker? Then we sensitize our eyes to warmer and cooler, and then gradually we move into the actual identification of those colors and the visible color spectrum. So eventually you start to say, what kind of warm is that? Is it an orange warm, a red orange warm? Is it a red warm, a magenta, a violet? You know, that sort of thing, okay? So I think it's pretty interesting that you can take these really neutral colors, but when you put them next to each other, they enhance each other.